This is another response video to Sandre. The title of his video is Twins Reared Apart and False Correlations of IQ video number 2. I know this video is from 2017 and doesn't have all that many views, but just the fact that this video exists and hasn't been responded to really irritates me, so I feel the need to correct the record. The purpose of this video seems to be to cast doubt on the idea that IQ is at least 50% heritable, or that we'll ever be able to conclusively say how much is due to genes or the environment. My main issue with this video which prompted this response is that it's just lazy, and not only that, but he references this video in several of his subsequent videos in his IQ video series, as if this video is the only thing that needs to be said about heritability of IQ, or at least the heritability of IQ based on quantitative genetics. By quantitative genetics, I mean using twin studies and kinship data to infer heritability, as opposed to molecular genetics where you're trying to find the individual genes responsible for a trait. Before getting into my response, we need to cover a bit of background. First, what heritability actually means, and second, an overview of twin studies and the criticisms of the methodology of twins reared apart. So first, heritability. The first thing I noticed in this video is the continued use of the word inherited. He also has a video titled, "Is Really Half of IQ Inherited?" which is an odd way to phrase that. Using the term half inherited is a giveaway that he probably doesn't understand this field very well. The half part probably comes from the finding that if you take all the twin studies that have ever been done and do a meta-analysis, the heritability of IQ is about 0.5 or 50%. The important part to understand here is this doesn't mean IQ is, quote, half genetic or half inherited. Heritability means something very specific, the proportion of variance in some phenotypic trait that can be accounted for by genetic variation. A heritability estimate essentially means for a given population exposed to a given range of environments, the variation in genetics in that population explains X% of the variation in this trait. What this means is that even if adult IQ is significantly influenced by genetics, if you take a population in, say, Minnesota, and then take a population in, say, Afghanistan, you're likely to find the heritability of IQ much higher in Minnesota because the range of environmental influences in Afghanistan is significantly more influential. On the other hand, if you lived in a communist utopia where everyone had the exact same environments, you'd instead find the heritability of IQ to be nearly 100%. The more you restrict the range of environments, the higher the heritability estimate will be. So basically, when people claim a 50% heritability of IQ, they mean specifically in the United States or maybe Western Europe in the modern age. And by the way, the figure of 50% is actually on the low side of estimates. If you restrict the sample to adults, the figure is closer to 75 or 80%. So now that we've covered heritability, let's briefly talk about twin studies. There are basically two types of twin studies, twins reared apart and twins reared together. In studies of twins reared apart, you separate the twins as early as possible, ideally in infancy, then raise them apart in separate home environments. The researchers aren't doing this, of course, but are instead attempting to find instances of this occurring. Anyway, later in life you then compare them in traits, such as giving them IQ tests, and you can use this correlation between the twins to estimate heritability directly. The primary method for estimating heritability is to use sets of identical twins reared together and contrast them with sets of fraternal twins reared together. Using some model fitting equations you can find from any behavioral genetics textbook, you can look at the correlation in a trait between the sets of identical twins and contrast that with the correlation in a trait between the fraternal twins and infer to what degree that trait is heritable. If a trait is highly heritable, there should be a stronger correlation between the identical twins because they share 100% of their genes, whereas fraternal twins only share 50% of their genes. In addition to twin studies, there's also family relation studies that look at non-twin sibling data and parent-child data. Another source of data is adoption studies, where you can look at how similar unrelated children raised in the same household turn out to be, which seems to be a quite good way to estimate the effect of the home environment. Using these studies, it has been found that nearly every human trait is heritable. According to this study, which attempts to meta-analyze every twin study in the last 50 years, the average heritability across all traits is 49%. But make no mistake, the one and only reason there is so much consternation about this topic is because of the heritability of IQ. In case you haven't watched Sandre's video, he summarizes the basic arguments from papers and a book by this guy, J. Joseph. The criticisms of twins reared apart studies are numerous, but I'll give you a sample for some context. The primary claim is that many of the twins were not sufficiently reared apart. Some were separated at a late age perhaps, or lived in very similar homes due to being raised by members of the same extended family, or had frequent contact with each other while growing up. And of course they had to know of each other's existence just to participate in the study. It's also possible that the twins or their family would lie or not tell the whole truth about the extent of their separation, due to the financial incentives to participate in the study. Also, the twins were unlikely to be a representative sample of twins reared apart, and it's questionable whether heritability estimates using twins could be generalized to the non-twin population at large. The point of these criticisms is that you cannot assume that the twins have completely separate environments, therefore the estimate of heritability of a trait would be inflated or completely invalid. This is just a taste of the numerous criticisms of twins reared apart. I don't think it's worth investing too much time in this video defending twins reared apart studies, because it's just one of the many methods for estimating heritability. So given that context, here's my main criticism of his video. One of the main problems I have with this video is he only attempts to discredit studies of twins reared apart. And that would be fine if he explicitly stated that the scope of the video was restricted to MZA twins, but if you read the disclaimer at the beginning of the video, it's obvious that he intends this video to debunk quantitative genetic estimates of IQ heritability in general. His disclaimer states, quote, "We do not know how much of intelligence is inherited and how much is due to environment, and it's possible we may never truly know. However, the vast majority of studies supporting the 50% or greater heritability of IQ are based on studies of twins reared together. There are ways of attacking these studies as well, namely the equal environments assumption. But Sandre doesn't even attempt this. He goes after the twins reared apart and seems to call it good. His video also isn't very coherent. Around 2 minutes in, he brings up the Minnesota study of twins reared apart, as if that will be the main focus of his video. He spends about 45 seconds on this study before pivoting to what are known as the classical twins reared apart studies. It's in these early classical twin studies, such as the Shield study from 1962, that have some of the most shocking-sounding examples of twins being considered to be reared apart, despite being separated at a very late age or clearly having very similar home environments. Some examples are one set of twins separated at age 9, and in another case twins living next door to each other and raised by separate aunts, and still being considered to be reared apart for the purposes of the study. For people critical of these kinds of studies, the Minnesota study is more difficult to attack because they attempted to place better controls to avoid situations such as those in the Shield study. The twin separation age has a relatively low average value, and the time to first reunion was relatively late in life on average. The main line of attack on the Minnesota study, which Sandre mentions in his video, is the unwillingness of the researchers to share data, especially data concerning fraternal twins reared apart, which serves as a kind of control group in these twins reared apart studies. Another reason I say Sandre's video is lazy is that he brings up serial Bert in his intro disclaimer, but then he doesn't even mention Bert during his actual video. I have only 2 short things to say about Bert. Whether Bert did indeed fake any data is very debatable, and even if you remove Bert's data, it doesn't change the overall picture of twin study data at all. Bert found a correlation of MZA twins at about 0.77. The Minnesota study found 0.75. After the Bert affair, basically every paper that analyzed twin study data removed Bert's data anyway, just to be on the safe side. Anyway, Sandre's primary source for these criticisms is The Trouble with Twin Studies by J. Joseph. This book basically consolidates every criticism of twin studies ever made all in one place. What this book does not reference, however, is basically any of the counter-arguments to these criticisms. Instead of getting into all the arguments and counter-arguments and all that minutia, I'm going to instead appeal to consensus and common sense, considering that neither Sandre or myself is a behavioral geneticist. In most of Sandre's videos, he's well within the scientific mainstream, but once you get into anything that forms a pillar of what you might call race realism, he gets increasingly into the fringe and well out of the mainstream on these topics. For example, just go to the Wikipedia page for the heritability of IQ. I'm not saying Wikipedia is an authoritative source, but as I've said before, if you find yourself arguing with Wikipedia on anything except an extraordinarily niche topic, it should at least make you think twice as to whether you're on the right side of an argument. Wikipedia says the heritability of IQ is roughly between 50 and 80%, and discusses how this is done with twin studies and so on. It does point out some criticisms, including linking to some papers by J. Joseph. But J. Joseph is a fringe critic. He thinks the heritability of IQ is basically 0. If you run a channel such as Sandre's that's presenting the science TM side of things, it's very disingenuous to use a book like this as the core of your argument without at least providing the context that this guy is way outside the mainstream on this topic. One guy I've criticized quite a bit in my last video, Eric Turkheimer, wrote a review of this book. Turkheimer is a behavioral geneticist, and he takes a very hard environmentalist position on the race and IQ topic. To give you a data point on Turkheimer, he almost certainly wrote the headline to this piece published in Vox that essentially says the bell curve is, quote, junk science. To see what I think about that, check out this video. Anyway, what does Turkheimer say about the trouble with twin studies? Here's how he ends the review of the book, and keep in mind, every argument Sandre makes is explicitly made in this book. Quote, "How could reasonable people differ so absolutely about the meaning of a body of empirical evidence? The response is, it is not a given that both sides of every argument are being reasonable. In the final analysis, this book is not reasoning forward from a known set of facts, seeking their explanation. It is confabulating backwards from a fixed conclusion, alighting any segments of the evidence that don't lead to the preordained destination. The trouble with twin studies is science denial." Another thing worth considering is that textbooks, such as this one, are used in universities across the world and present these studies of twins reared apart as one of the many ways we can estimate heritability of various traits, including general cognitive ability, which is a fancy way of saying IQ. So, I'll now present some arguments and evidence as to why quantitative genetic estimates demonstrate the heritability of IQ is probably at least 50% in the modern Western world. This chart is from the Wikipedia article for the heritability of IQ. If you think this chart has a bogus source, feel free to present an alternative in the comments, but this chart appears to roughly match every other compilation of correlation coefficients I've seen for twins reared together, twins reared apart, parent-child, sibling, adoption, and so on. There is one caveat to the fraternal twins reared together, which we'll get to in a moment. Before we get into these numbers, let's review what the hereditary imposition on IQ is. The variation in IQ is 50 to 80% due to variation in genetics, and 20 to 50% is due to environment. And critically, the heritability of IQ increases with age, reaching a maximum in the mid-20s and staying fairly stable from then on. Another assertion of the hereditarian argument is that the home environment, also known as the shared environment, meaning the environment the siblings share, has almost no effect on adult IQ. For adults, an upper bound on this would be about 10%. However, it appears that what is known as the non-shared environment does have a significant effect on adult IQ, accounting for maybe 50 to 20% of the variance. The non-shared environment is thought to be idiosyncratic random events and peer groups and so on that the siblings do not share. It is also thought that the non-shared environment could be somewhat genetic in itself, meaning that a person's genetic predisposition will cause them to seek out environments that align with their genotypic IQ. Anyway, setting the various components of environment aside, does this data comport more with an environmental explanation of IQ or a hereditarian explanation? Each of these values are an intra-class correlation coefficient. It basically represents how similar, on average, each of these groups are among themselves in IQ scores. These correlations represent the shared variance among the group, and therefore these values can be directly used to apportion the genetic and environmental variance components. For the simplest model, we consider the total variance of the phenotype to be equal to the variance due to genes plus the variance due to environment, which totals to 100%. In this case, if we can estimate the effect of the environment, we can use this value to estimate heritability. One way to estimate the effect of the environment is to note how much the correlation differs from the correlation we'd expect if the trait were 100% due to genes. For identical twins, we'd expect a correlation of 1. For biological siblings, we'd expect 0.5. And for parent-child, we'd also expect 0.5. To estimate the effect of environment, let's compare those values to identical twins reared apart, biological siblings reared apart, and parent-child living apart. Using these values leaves you with an environmental variance of between 24% and 28%, and therefore a heritability estimate between 72% and 76%. This is a very simple model though, so don't take these results too literally. The point is, these three different estimates of the environment give extraordinarily similar figures. Another interesting data point to consider is the difference in interclass correlation between people raised together as children and then as adults. This data basically shows two things. The variance attributed to the shared environment is around 20 to 25% in children, but basically zero by adulthood, as demonstrated by the unrelated children reared together. However, as I've said earlier in the video, the primary method to make heritability estimates as accurately as possible is with twins reared together, namely using the difference between identical twins reared together and fraternal twins reared together. For example, in 1990, this paper used sophisticated model fitting, a large dataset of over 10,000 twins, and accounted for a wide variety of confounding variables and found the best estimate of heritability of IQ to be 51%. This paper is probably the primary source of the claim that heritability of IQ is around 50%. However, starting in the early 90s, it was becoming increasingly apparent that heritability estimates of IQ increase with age. This paper was one of the first to address this directly. They noted that the previously mentioned paper that estimated the figure of 51% used twins that were primarily adolescents and nearly all of which were under the age of 20. The authors of this paper incorporated data taken from identical and fraternal twins reared together well into adulthood and found the following. While identical twins reared together maintain a fairly stable IQ correlation, it appears that fraternal twins reared together approach the similarity of non-twin siblings reared together later in life. Using this data, MZT versus DCT estimates of heritability is about 80%. The authors note that this finding may resolve the outstanding question as to why twins reared apart gave so much higher heritability estimates than twins reared together. The simple reason is, in studies of twins reared apart, the sets of twins were studied well into adulthood. When sets of identical and fraternal twins reared together were also studied well into adulthood, the heritability estimates turned out to be quite similar. To quote the authors, "Given the consistency of MZA IQ correlations across studies, the relatively large MZA IQ correlation is more likely to reflect an increase in heritability into adulthood than bias in MZA sampling or assessment." It should be apparent at this point that many different lines of evidence based on kinship correlations all cluster around a heritability of IQ of 70 to 80%. Guys like J. Joseph can of course throw up objections like non-complete separation and equal environments assumption and so on. But when you have these different lines of evidence all arriving at approximately the same number, you'd need these separate violations of assumptions to also line up in such a way that they have approximately equal effects. For example, you'd have to say that the effect of non-complete separation of twins reared apart has an extremely similar effect as to identical twins reared together being treated more similarly than fraternal twins reared together. These two separate effects would have to amplify the apparent heritability such that both methods arrive at about the same figure. Denying this evidence based on violation of assumptions requires a fine-tuning of these various effects that, in my opinion, seem implausible. However, rather than just appealing to parsimony and common sense, there is now another line of evidence that further bolsters the validity of kinship and twin study data. There is now molecular genetic evidence, and while it does not as of yet come up with similar figures as twin studies, it at least places bounds on how much violations of twin study assumptions actually matter. One method that isn't much help, but I'll mention for completeness' sake, is GWAS, or genome-wide association studies. Unfortunately, GWAS studies still produce relatively low heritability figures even for traits which we absolutely know are highly heritable, such as height, but even these low figures have problems replicating. J. Joseph talks quite a bit about this in his book. My simple response to this is, when you get a GWAS study that shows a heritability of height at something like 0.8, let me know. When that day comes and GWAS still shows a low heritability of IQ, then I will pay attention. But until then, pointing out that GWAS studies show low IQ heritability is kind of a dumb argument, because GWAS also doesn't show height as being very heritable either. A method that has shown more promising results as of 2019 is genome-wide complex trait analysis. This is a relatively recent technique that allows for a kind of genome correlation coefficient between completely unrelated people, which can then be correlated with a phenotype such as an IQ score. Note that this technique completely bypasses all the assumptions made in twin studies. You no longer have to worry about complete separation of twins, correlated environments, equal environments assumption for twins reared together, or anything like that. You take two unrelated people, compare how similar their genomes are, then correlate that with their IQ or whatever trait you're interested in. It's important to note that for a number of technical reasons, GCTA is a lower bound estimate on heritability. The most important reason for this is that it uses a sample of the genome rather than the whole genome. In this 2014 study, GCTA was used on sets of twins so that the GCTA and twin estimates could be compared directly in the sample population. At age 12, twin estimates yielded a heritability of 0.49 and GCTA yielded 0.45. It's important to remember that a figure of 0.4 to 0.5 for 12-year-olds is about what you would expect given the Wilson effect and an adult IQ heritability of about 0.75. GCTA studies generally find a heritability of IQ between 0.3 and 0.5 for adults. Given that this is a lower bound, this is strong evidence that violation of assumptions in twin studies are of limited utility if you're trying to debunk quantitative genetic heritability estimates. Consider this quote from Eric Turkheimer, which is in the same article where he's attacking Charles Murray and Sam Harris. Quote, "Today we can also study genes and behavior more directly by analyzing people's DNA. These methods have given scientists a new way to compute heritability. Studies that measure DNA sequence variation directly have shown that pairs of people who are not relatives, but who are more similar genetically, also have more similar IQs than other pairs of people who happen to be more different genetically. These, quote, DNA-based heritability studies don't tell you much more than the classical twin studies did, but they put to bed many of the lingering suspicions that twin studies were fundamentally flawed in some way. Like the validity of intelligence testing, the heritability of intelligence is no longer scientifically contentious." You may find a quote like that odd to be included in an article attacking Charles Murray, but Turkheimer's point is that even if you accept IQ as a valid construct, and that IQ is moderately heritable, and that races differ in average IQ, that it does not directly follow that the race differences are genetic in origin. So, to sum up Sandre's video, he's attempting to debunk quantitative genetic estimates of the heritability of IQ by referencing the arguments of basically one source that is way outside the scientific mainstream, concentrating only on twins reared apart, and ignoring the vast body of evidence from twins reared together, family relation studies, and adoption studies, and failing to mention any response to these criticisms he makes of twin studies in general. As I've demonstrated here, the basis for quantitative genetic estimates of IQ is not primarily based on twins reared apart, and that there's a broad, interlocking body of data from twins reared together, siblings, and adoption studies that show a rough 70 to 80% heritability of IQ by adulthood. This is also the position of the American Psychological Association, by the way. And finally, that GCTA estimates demonstrate that any violations of assumptions in twin studies are probably not as significant as critics of twin studies, such as J. Joseph, would have you believe. If I were Sandre or any of these Kraut and T academics, I would read Turkheimer or better yet, James Flynn and just copy their positions. That way you can at least stop engaging in science denial, but still have an out in terms of the race and IQ stuff. You can admit that IQ is a useful and valid scientific concept, and that IQ is highly heritable, but still, at least for now, have a somewhat credible space to occupy in terms of denying that racial differences have a genetic component.